Hello, good morning, everyone. I would like to thank the Medea and FIRE-IN projects for the invitation. I'm Stelios Andreadis from Infalia, and I will present the Flood Forward social media tool. Okay, so Infalia Private Company is a spin-off company of the Center for Research and Technology Hellas, and specifically the Information Technologies Institute. It's located at Pillea in Thessaloniki, Greece. In May of 2013, there was the bilateral agreement with CER to have a spin-off, while from the beginning of 2014, the company was officially founded, and all of its initial founders are experienced researchers at CERT-ITI. In August of 2016, the company was also accepted in the VP Technologies Incubator Center. The expertise of the company is in three major research pillars: smart city solutions, visual analytics, and big data analytics, while the overall activities involve artificial intelligence and machine learning, computer vision, web data mining, social media analysis, semantic reasoning, multimedia retrieval, and data fusion, among others. The company is currently participating in 8 ongoing research projects. 2 of them are Horizon 2020, DeepCube and Spider in particular. And we're developing software solutions, both front-end and back-end, web applications and mobile apps. So I'll give you some background for the development of the presented tool. So, as everyone knows, there is a wide adoption of social media in our daily lives, and now valuable information is also exchanged during natural hazards, which include flash floods. So people are posting on social media platforms about early signs of extreme weather, areas at risk, or humans, animals, infrastructure in danger during the disaster, and also some important advice, for example, information on places of relief. We believe that this info needs to be communicated to security practitioners in order to increase the situational awareness with a more modern means of reporting as supplement to traditional ones, like, for example, through phone. On top of that, part of this information probably needs to be efficiently redistributed to the general population in order to timely alert them. So we propose the Flood Forward social media tool, which provides practitioners with an automatic and friendly way to first receive flood-related posts from Twitter and also to forward them to the general public. The tweets are filtered, geotagged, and summarized. I will provide more details in the next slides about that. And also, web application offers visualization of these collected and analyzed posts and gives the user the option to either post an auto-generated message based on summaries created through the analysis of the tweets, and the option to retweet any of these tweets. Both post and retweet are realized through the practitioner official account, and there is no need to log into Twitter or to open the Twitter webpage in a separate site. So the Flood Forward social media tool addresses 2 capability gaps in the domain of flash floods. Capability gap number 1 is the need for improving awareness of population toward natural hazard alerts. And how is this achieved? The tool offers efficient communication towards the general public during a flood, since it provides an easy way to disseminate information by posting auto-generated tweets or retweet tweets that already exist. The tool also enhances the reliability of this disseminated info in an automatic way, which is a machine learning model that predicts the relevance of each post and disregards the irrelevant ones, and in a not automatic way where the practitioner can examine the crowdsourced information and edit the auto-generated message before posting it. The second capability gap is the need for an automatically real-time situational awareness and decision support system. Our solution can significantly increase situational awareness with up-to-date crowdsourced data and assist the decision making because the tweets are retrieved nearly real time, and we provide timely notification to the first responders or authority representatives about flood events as they are expressed on Twitter. We also filter information in terms of quantity because we cluster multiple posts that refer to the same event. This is what we call summaries. And in terms of quality, because we estimate whether a tweet is valuable or if it's noise or misinformation and is disregarded. Now some more detailed description of the solution. So Flood Forward comprises a collection and analysis toolkit in the backend and a web application user interface in the front end. The first part of the backend is the collection. So we've built a crawler that establishes an open and continuous connection to the Twitter API and retrieves in real time tweets that contain predefined flood-related keywords. For example, in this tweet contains the keyword flood, so it will be retrieved if the keyword flood was in the search criteria. Then the first analysis we do is the relevance estimation. This is realized with binary text classification. So we have a classifier that decides whether a new tweet is relevant or irrelevant. And for this automatic classification, we use pre-trained models with human annotation from experts on English and Italian tweets. And the outcome of this is to filter out noise. For example, we can see here two tweets that both contain the keyword flood. Thus, they will be retrieved, but one is irrelevant because it refers to flooding Twitter, which means posting a lot about the topic. A second analysis is the geotagging. So we apply named entity recognition and deep learning combination in order to detect which words inside the text of a tweet refer to locations. And we automatically geotag them with a query to OpenStreetMap API. So we query the word and we get the exact coordinates. Again, this geotagging is supported both in English and Italian languages. Here is an example where in the Italian text of this tweet, via Matteo Bonello is mentioned. So we get the full address from OpenStreetMap API as well as the coordinates, the pair of coordinates, in order to be able to place it, for example, on a map. Finally, we also apply event detection with a methodology of outlier detection. So we try to identify peaks in the Twitter activity. By Twitter activity, I mean how many tweets are posted per day. And then to cluster posts that are close in time and location, assuming that they refer to the same incident. In this way, we create the summary reports. So when a new event is detected, one of these reports is created and the practitioner is notified. In this plot, you can see the peaks in Italian tweets between 2017 and 2019 and the floods they refer to. Now moving on to the front end, we have implemented a web application where the user can view the alerts positioned on a map based on the geotagging methodology, and also to read the respective event reports with all the detailed tweets. Also, there is the option to post an auto-generated message which reads the number of relevant tweets, the most mentioned keywords, the affected area, and this message is editable, which allows the user to type custom text. Also, there is the option to retweet any tweets of the report, and everything is realized through the official Twitter account of the practitioner, which yeah, without the need to log in. I'm closing with this slide where we can see what has been completely developed and tested, and what is still ongoing work. So we're still working on the user interface, and basically the part where we have to finalize is the summaries, the reports, and the option to post auto-generated message and retweet, which have been already done, but they have to be integrated in the user interface. Thank you very much. If there are any questions, please post them on chat, and or you can contact us. Thank you very much.